Good morning students, welcome to my class again. This is the 8th class and the last class of chapter number 4. In this class we are going to solve the homework of class number 7th. The questions that I was given in class number 7 are as follows. The first question is find the value of p for which the quadratic equation p plus 1 x square minus 6p plus 1 x plus 3 into p plus 9 equals to 0, where p is not equals to minus 1 has equal roots, hence find the roots of the equation. Question number 2 is given by solve for x, that means we have to find the value of x, and the equation is x square plus 5x minus a square plus a minus 6 equals to 0. Then third one is again solve for x, and the equation is given by x square minus 2b minus 1 x plus b square minus b minus 20 equals to 0. Fourth one is again solve for x, and the equation is x square minus 6x minus a square plus 2a minus 8 equal to 0. And the last question is given by find the value of p so that the quadratic equation p x into x minus 3 plus 9 equals to 0 has equal root. Let's solve the given question one by one. Okay, question number 1. Find the value of p for which p plus 1 x square minus 6 p plus 1 into x plus 3 into p plus 9 equal to 0, where the value of p is not equals to 1 has equal roots. Hence find the roots of the equation. If you understand this question, it is very clear that the roots of the given quadratic equation are equal. That means if the roots are equal, then we have d equals to 0. As per the condition, we know that if the roots are equal, then d equals to 0. That means b square minus 4ac equals to 0. And if we compare this quadratic equation with a standard form, then we can get the value of b as p plus 1. Sorry, the value of a is p plus 1, not b. The value of a is p plus 1. The value of b is minus 6 into p plus 1, and the value of c is 3 into p plus 9. And if you substitute these values in the given equation, we can write minus 6 into p plus 1 whole square, that is b square, minus 4 into a is p plus 1 and c is 3 into p plus 9 equals to 0. Clear? And if you further simplify this one, then this can be 6 6 are 36. P plus 1 whole square is p square plus 2p plus 1 minus 4 3s are 12 into p plus 1 into p plus 9 equals to 0. If you further simplify this one, we can write 36p square plus 36 2s are 72p plus 36 minus 12 into p is p square plus 9p p square plus 9p plus p plus 9. P into p is p square, p into 9 is 9p, 1 into p is p, and 1 into 9 is 9 equals to 0. Clear? Next, 36p square as it is plus 72p plus 36 minus 12p square 9p plus p 10p 10 into 12 is 120p minus 120p minus 12 9 ja 108 equals to 0. Now 36p square minus 12p square equals to 6 minus 2. 6 minus 2 is 4 and 3 minus 1 is 2. 24p square, then plus 72p minus 120p, plus minus is minus, therefore 122 minus 72. If you subtract 72 from 120, then it will be equals to 10 minus 2 8, 11 minus 7 7 plus 4 11, 48 minus 48p minus 36, sorry, plus 36 minus 108 minus 36 2, and 10 minus 3 72 minus 72 equals to 0. It is very clear that if we divide all the terms by 24, then it can be written as p square. 24 2 ja 48, 24 2 ja 48, and 24 3 ja 72 equals to 0. This can be written as p square minus 3p plus p minus 3 equals to 0. This can be further written as p. If we take p as common, then inside there will be p minus 3. Here p is 1 is common, p minus 3 equals to 0. Therefore p minus 3 into p plus 1 equals to 0, and this implies p equals to 3 and p equals to minus 1. But p equals to minus 1 is not possible. This one is not possible. Okay, therefore p equals to 3. Now we have find the value of p. Now we have to find the roots of the equation. Therefore the equation can be written as 3 plus 1 into x square minus 6 into 3 plus 1 into x plus 3 into 3 plus 9 equals to 0. 4x square minus 3 plus 1 4, 6 4s are 24, 6 4s are 24x plus 9 plus 3 12, 12 3s are 36 equals to 0. Therefore x square minus 4 6 are 24 and 4 9 are 36 equals to 0. Therefore this can be written as x square 9 3 3 is 9 minus 3x plus 9 equals to 0. X is common, inside there will be x minus 3 is common, x minus 3 equals to 0. Therefore x minus 3 into x minus 3 equals to 0. Therefore the value of x is 3. Okay, hence roots are 3 and 3 respectively. I think it is clear to all. Solution number 2. The question is solve for x. That means you have to find the value of x. The first equation is x square plus 5x minus a square plus a minus 6 equals to 0. It is very clear that it is a quadratic equation. If we compare it with the standard form, we will get the value of a as 1. The value of a as 1. The value of b as 5 and the value of c as minus a square plus a minus 6. Suppose we are going to use the quadratic formula method to find the solution, so that we have to find the value of d first. So d equals to what? B square minus 4ac. That means 5 square minus 4 into a is here 1 and c is here minus a square plus a minus 6. 5 5 is 25. If we take this minus outside, it will be plus 4 into a square plus a minus 6. And if you further simplify this one, 25 as it is plus 4a square plus 4a plus 4a square plus 4a, and 4 6 are 24 minus 24, and this can be written as 4a square. Okay, this can be written as 4a square plus 4a, and this 25 minus 24 is plus 1, and this can be written as 2a plus 1 whole square, because if you expand this 2a plus 1 whole square, it is 2 to the 4a square plus 2ab means 2 to the 4a, and plus 1 square is 1. That means if we find the square root of d, then it can be written as square root of 2a plus 1 whole square, right? And this can be written as 2a plus 1. Okay. Now we have a formula, quadratic formula, that is given by x equals to minus b plus minus under root d upon 2a. Therefore x equals to, here b is how much? B is 5. Therefore minus 5 plus minus, and the value of d is 2a plus 1. 2a plus 1 upon 2a. Therefore this can be written as minus 5 plus minus 5 plus 2a plus 1 plus 2a plus 1 upon 2a, and x equals to minus 5 minus 2a minus 1 upon 2a, and the value of a is here 1. Okay, that means this can be written like this one. This can be written as x equals to 2a as it is, minus 5 plus 1 is minus 4 upon 2. Therefore x equals to a minus 2 as one value. In the second case, x equals to minus 2a as it is, minus 5 minus 5 and minus 1 is minus 6 upon 2. Therefore x equals to minus a minus 3. Got it? Similarly, you can solve the question number 3 also. Here the equation is x square minus 2b minus 1 into x plus b square minus b minus 20 equals to 0. If we compare it with standard form of quadratic equation, then a equals to 1, b equals to minus 2b minus 1, and c equals to b square minus b minus 20. Therefore, d equals to b square minus 4ac. Therefore, here the value of b is minus 2b minus 1 minus 2b minus 1 whole square minus 4. The value of a is 1 and the value of c is b square minus b minus 20. Okay, if you further simplify this one, you can write this as this minus whole square is plus this 2b minus 1, that is 4b square minus 4b plus 1, and if you multiply this 4 inside, 4 on the 4, and if you multiply this 4 inside, this will be minus 4b square minus 4b square minus minus plus 4b minus minus plus 4b, and this minus minus plus 24 is 80. This 4b square and 4b square cancel out, minus 4b and minus 4b is cancel out, 80 plus 1 is 81. Therefore, square root of d is square root of 81, and this can be written as 9. Okay, now x is given by minus b plus minus under root d upon 2a. So this implies the value of b is here minus 2b minus 1. Therefore, this can be written as 2b minus 1 plus minus under root d is 9 upon 2 into a is here 1. Okay, therefore this can be further written as x equals to 2b minus 1 plus 9 upon 2, and x equals to 2b minus 1 minus 9 upon 2. If you solve this one, this can be written as 2b plus 8 upon 2. This can be written as b plus 2 4 is 8. Therefore, x equals to b plus 4 as one solution. In the second case, this can be written as 2b as it is minus 10 upon 2, b minus 2 5 is 10. Therefore, the second solution is b minus 5. Clear? I think it is clear to all of you. Now, similarly, if you solve the question number 4th also, here also the value of a is given by the value of a is given by the value of a is given by 1, the value of b is given by 6, and the value of c is given by minus a square plus 2a minus 8. Therefore, d equals to b square minus 4ac, and the value of b is given as 6 square minus 4 into 1 into into minus in a square plus 2a minus 8. 6 6 are 36, minus minus plus 4a square plus 4 2 are 8a and minus 32, and it is equals to 4a square plus 8a, and 36 minus 32 is 4. Okay, it is very clear that 4 is common. If we take 4 as out, inside there will be a square plus 2a plus 1, and this can be further written as 4 into a plus 1 whole square. Therefore, if we find the value of square root of d, then it can be written as 4 into a plus 1 whole square, and it is equals to 2a plus 1, or you can write 2a plus 2. Therefore, the value of x is given by minus b plus minus under root d upon 2a. Therefore, x equals to minus 6 plus 2a plus 2 upon 2 into 1, and x is given by minus 6 minus 2a minus 2 upon 2 into 1. If you solve this one, you will get the value of x as minus 6 plus 2 is minus 4, 2a minus 4 upon 2. Therefore, x is given by a minus 2, here x equals to minus 2a minus 8 upon 2. Therefore, x equals to minus a minus 4. Therefore, the value of x is given by a minus 2, and the value of a is given by minus a minus 4. I think it is clear to all of you. Now the last question: find the value of p so that px into x minus 3 plus 9 equals to 0 as equal root. First of all, we have to write this equation into standard form of quadratic equation. If we simplify this one, this can be written as px into x is x square minus 3px plus 9 equals to 0. If we compare this by standard form of quadratic equation, the value of a is p, the value of b is minus 3p, and the value of c is 9. Now it is given in the question they have equal roots. They have equal root means we can write d equals to 0, and if g equals to 0, that means b square minus 4ac equals to 0, right? Therefore, we can write minus 3p whole square minus 4 into a is here p, and c is here 9 equals to 0. 3 3s are 9, p square minus 9 4s are 36p equals to 0. Now it is very clear that 9p is common. Therefore, inside there will be p minus 9 4s are 36 equals to 0. Therefore, 9p equals to 0, or p minus 4 equals to 0. Therefore, p equals to 0 or p equals to 4. But p equals to 0 is not possible, because if we put p equals to 0 in the given equation, it will be not going to be a quadratic equation. This whole term will become 0. Therefore, it will not going to be a quadratic equation. Therefore, the value of p is 4. I think it is very much clear to all of you. Okay, this is all about for this class today. In the next class, we are going to start with the new chapter. Thank you, students.